Now, in triangle ABC, AB equals 12 and BC equals 9, yeah? And angle BAC equals 42 degrees. Cool. So let's just sketch this out for a second here. So you got A, B, and C. So let's say A, B, C. AB is 12, BC is 9, angle BAC is 42. Alright? Now, A. Find in degrees to the nearest 0.1 degrees each of the two possible sizes of angle ABC. So we're talking about angle ABC. So we're talking about here. Okay. An easy way to find the value x, guys, is to firstly work out the value of the angle next to C, yeah? So let's just call this angle here y for the sake of it. Now, what I would do is that I would use either the sine or the cosine rule, because these are the rules that always work for triangles. Now the trick is, if you're working with 3 lengths, then you're using the cosine rule. If you don't, then you have to use the sine rule. So let's match up what we know, yeah? According to the sine rule, we match up length with angle. So we've got 9 over sine 42. That's one of them. Now we need to find something else. Well, we also have 12 over sine y. Okay, cool. So now all we have to do is pretty much rearrange to make sine y the subject. So another way you could do this is write it upside down. So we're going to have either sine 42 over 9 equals sine y over 12. This is easier because that way we can just multiply 12 across to get sine y. So multiplying 12 across, guys, yes, I'll do it here. We're going to now have 12 times sine 42 over 9, and that equals sine y. So go ahead and put this in your calculator, and oh yeah, make sure your calculator is set to degrees mode, yeah? The reason why is because in question 1, you probably had it set to radian mode. So you have to set it back, otherwise your answers look a bit funny. Now work this out, guys, and then when you get a result, sine inverse that answer, yeah? And that will give us our result for y. And when you do that, you should get a y result of 63.1 degrees to 1 decimal place. Okay? Now, another thing you also need to do is, let's have a look. Yeah, so because they want, two possible sides of angle ABC, we should also have 2 possible sides of angle y, yeah? Because of the sine, sine property, they'll either think that you get an obtuse angle or an acute angle, so they're not really clear. At the moment, we've got an angle less than 90, so this is acute. To get the obtuse version, you just got to take this away from 180. So let's just call this the first angle, yeah? To get the second angle, it's going to be 180 take away 63.1, and this should give us 116.9. So this is our second angle, our obtuse version. Now that we've got y, we can work out x. So let's do this. So therefore, to get x, guys, yeah, it's going to be, well, we know all angles in triangle add up to 180. So we can subtract 42 and one of these pairs. So let's subtract 42 and 63.1 from 180. If you do that, guys, that means the third angle will end up being 74.9. That would be your acute one. Now, if you use the other one, if you subtract the obtuse angle, so you got 42, 180 take away 42, take away 116.9. Your other tiny angle would be 21.1 degrees. And that's it, guys. You got your 2 pairs of angles. Now, for the last part, part B, it says find to 2 significant figures the smaller of the 2 possible areas of triangle ABC. So again, to do that, you just got to use an area of a triangle formula. So let's do it. Well, because your triangle isn't a right angle and you haven't got any, you don't know if this is a base or not, we should use the other area triangle formula, which is the half AB sine C rule. Okay, we just need to pick two lengths between an angle. So let's focus on x here. So we're going to basically take this shape. These two will be our A's and B's, and this will be our C. We could say that the formula now is half times 12 times 9 sine and then x. Okay, well, if you want to pick the smaller area, you're going to pick the one that has a small angle. So using 21.1 for x, if you substitute that in, so just replace this with 21.1, you're now going to get an area of, if you do it carefully in your calculator, guys, roughly 19 centimeters squared to 2 significant figures. And that's it.